I take this problem very personally here in my mid 50s. Every time I get up, I'm reminded that the only thing that keeps your cartilage um, fed with nutrients and everything is actually compressing it and letting the pressure off. But here, this is all about the osmotic pressure of collagen within the cartilage. So you've got all these fibers that hold everything together, um, and the the collagen fibers are holding things together, and you've got inside of here, right, PG, which what is proteoglycan molecules in here, right, that are bound, not bound, but they're stuck inside the cartilage, and that pressure causes this to be inflated, if you will, and more of a cushion. And so we want to look at that, right, versus the um, uh, the pressure outside due to fluid there. And um, so we've got our osmotic pressure, right? We've got um, a polyethylene glycol solution with its osmotic pressure on the outside in this study, looking at this. And if you look at the, what is our pressure here? We start off with 4 atmospheres, got no pressure here. And as you increase the pressure on the outside, the pressure on the inside goes up until you've completely compressed this is the cartilage as far as it's going to go, and you're way up at 10 atmosphere. All right, so what is the excess pressure exerted by the collagen measure under normal conditions, right? I'm going to just walk through these. Let me look real quick to see what I asked you in Canvas, because I asked you in Canvas, question answer. Okay, only exerts 2.2 atmosphere. How much of that tissue will the tissue swell? By what percentage will its volume change? And here I gave you the article that all of this comes from. All right, so let's go back to the problem and let's talk through this. Well, when here, I mean, it seems ridiculous, right? We've got 4 atmospheres. That's the answer on A. We've got 4 atmospheres there. Um, at what value does the collagen do the collagen fibers no longer do any work, or not work, but exert any pressure? Well, I mean, that's up here, right? At what value of the external osmotic pressure? Well, that's up at 10 atmospheres, right? That's where the collagen fibers are no longer doing anything, right? Because this difference in pressure is what the collagen fibers are dealing with. Okay, so at this point at 10 atmosphere, there's no tensile stress on the collagen uh, uh, fibers. And you plot these, you can get a nice little linear equation for them. Well, PC, which is their difference, right? PC is this column minus that column. So you can plot that and get the linear relationship there. If the collagen arthritic joint can only exert 2 atmospheres, so we're at 2 atmospheres down here, by how much will the tissue swell? I.e., by what percentage will its volume change? All right, and so this is this has to do with if all right, how much will it swell? If we're down here at 2 atmospheres, and that's all we've got. Now you got to remember, we've not we've not taken out any proteoglycan. I hope I'm saying that correct. We're not taking any of that out. That's still there. It's just our pressure is way down. If that's all that it can exert is 2 atmospheres, what's going to happen, right? You're going to end up with fluid, with basically the fluids in the body making their way into this, and this is going to swell until you get to the point where the pressure on this side is the same as the pressure on the other side. And in this case, that's going to be a factor of 2, right? So for B and D, it's only these are the only things causing osmotic pressure, and their number does not change, right? And so we've got to add water to get to the point where we balance things out again, and uh, and in this case, that means this cartilage here has to be twice as large um, to get to make up for the fact that we're only at 2 atmospheres instead of 4. Think, yeah, I think that's it. And one last detail, what what percentage will it change? So I said this will increase by a factor of 2. In this instance, well, that's 100% increase in the size of the cartilage, right? So you got to look at the ratio of your 4 atmospheres to your 2 atmospheres minus 1 times 100%. And so in this case, the increase is 100%. And that's it for this cartilage problem.